Alright, so example 8 is one that you could do a couple of different ways, and either way is fine, but there's one way that's easier. And so the first way that you could do it is most people here would probably try to turn everything into sines and cosines and then find a common denominator, and you could do that and that would work. It would just take a lot longer. So I'm going to show you the easy and faster way. And so what I notice when I look at this is that both of these factors or parentheses are the same except for the signs. And so I know that whenever I FOIL things out that have different signs and are the same factor but the signs in the middle are different, then the middle terms cancel out, and so really all I have to do is multiply the outsides and the insides. And so I'm going to do that because it's going to end up giving us tangent squared minus secant squared. And so that, whenever I have two things that are squared, is a Pythagorean identity. And so the Pythagorean identity that goes with is this one. It has a tangent squared and a secant squared. And so I'm going to copy that over here, and we're going to have to do something to make it look like what we've got. So I've got 1 plus tangent squared equals secant squared. I need, to simplify this, I need tangent squared minus secant squared. So if I minus the secant squared over, I would have 1 plus tangent squared minus secant squared equals 0. But then I also need to move this 1 over. So this is going to give me tangent squared minus secant squared equals a -1 when I subtract it over. And so I know that this tangent squared minus secant squared is really just -1. So that simplifies down really nice to just -1. And now you could go through that and get your common denominators and turn everything into sines and cosines, but it would take a lot longer to do that. So that's how I would do number 8. Alright, number 9 is just one that looks obviously like one that you need to get a common denominator on because you've got two fractions, different denominators, and so that's what I'm going to do is get my common denominator. So this needs a sine, and this needs a 1 plus cosine. And so in the top, that'll leave me with sine squared plus, I'm going to go ahead and distribute this cosine. So this is cosine plus cosine squared. And then all over common denominator, which is just sine, and then 1 plus cosine. Now, even though these three factors are not necessarily in the right order that I need them to be right now, since they're all addition, I can just move them around. And so, right quick, if we had 3 plus 2 plus 1, I could rewrite this and say that is really just 5 plus 1. And so I can combine things that will combine, since it's just addition, in any order that I want. And so what I'm going to do is rewrite the top and make this sine squared plus cosine squared plus cosine all over my common denominator, sine, and then 1 plus cosine. Now, the reason that I did that is because these two things, when I add them, when I add sine squared plus cosine squared, you should, since we've been using that one a lot, realize or notice that this is just going to be 1. So I really, right here, just have 1 plus cosine over sine, and then times 1 plus cosine. Well, that whole term, that whole factor, 1 plus cosine, will just cancel out, and it'll leave me with 1 over sine. And I don't want to leave fractions, and I know 1 over sine is a reciprocal identity, so I'm just going to go ahead and make that cosecant. And so then cosecant would be my simplified answer. Alright, last example, number 10. Okay, so this one's another obvious one where it's easiest to probably just go ahead and get a common denominator. And so over here, this needs a 1 plus sign. This needs a 1 minus sign. And so instead of writing all that out, I'm just going to say 1 plus sign, 1 minus sign. Alright, so then in the numerator, I'm going to go ahead and distribute the 1s. It's not really going to change anything. This is just going to be 1 plus sign plus 1 minus sign. Okay, all over this 1 minus sign and 1 plus sign, my common denominator. And so I'm going to go ahead in the top and simplify. If you'll notice, the signs have opposite signs, so they're going to cancel. And so then that's just going to leave me with 2 over 1 minus sine, 1 plus sine. Now, you're probably thinking, that looks kind of complicated, and it's got fractions, and I can't leave fractions, and I can't turn it into sines and cosines. And so what you're going to do is, again, notice that these two factors in the bottom are the exact same except for one's plus and one's minus. And so I'm going to go ahead and FOIL those out. And so that's just going to give me 2 over 1 minus sine squared. And so I see a 1, I see a sine squared in the same expression, or in the same denominator. And so I'm going to automatically think cosine squared plus sine squared equals 1, that Pythagorean identity. And so if I wanted to make my identity look like the problem, then I would just subtract my sine squared over. So cosine squared is going to equal 1 minus sine squared. And so then whenever I plug in for that, this is just going to be 2 over, I'm taking this cosine squared and I'm going to plug it in to the 1 minus sine squared. That's the same thing. So I've really just got this. And so I can't leave fractions. And so to make this not be a fraction, what we can do is just raise that cosine up to the top. I know that cosine, this is just a reciprocal identity. I'm going to do this down here in a little box. I know that cosine is just 1 over secant. Okay, so if I have cosine squared, that's just 1 over secant squared. And so if I've got cosine squared, when I move that to the top, or rewrite it with using our reciprocal identities, I can, first of all, I'm just going to show this extra step, and you don't have to show this step unless you just want to. I'm going to write this as cosine squared, and then a 1 over it, because this is the exact same thing. I would just multiply the 2 to the 1 and get this back. And so this, I write it like this in my examples to hopefully help you see that this expression right here is really just going to be secant squared. And so then my final answer would just be 2 secant squared theta. And I'm pretty sure you have some problems like this to do.